Right now, more than 50,000 commercial ships are operating across the world's oceans. Yet strangely, these giant vessels can stay in one place, thanks to a system hidden beneath the water. Many people believe that the anchor itself keeps a ship from moving. But in reality, if you simply drop an anchor into the water and do nothing else, the ship can still drift away as if nothing happened. So what is really keeping these massive floating cities in place against the waves, wind, and powerful ocean currents that never stop moving? Anchors have been around for more than 4,000 years, long before humans built steel ships or massive engines. Ancient sailors used large stones tied to ropes to keep their boats from being carried away by currents. Over time, those simple designs gradually evolved into the modern anchoring systems used on ships today. Although their shape and materials have changed dramatically, the purpose of an anchor has remained the same: to keep a vessel in place when needed. But the surprising thing is that a modern anchor does not work the way most people imagine. To understand how ships weighing hundreds of thousands of tons can remain stationary at sea, we first need to uncover the secret hidden beneath the water. When people think about anchoring a ship, most assume that the anchor itself is what keeps the vessel in place. In reality, the anchor is only one part of a much larger system. The component responsible for most of the holding power is the massive steel chain connected to it. On large ocean-going ships, an anchor chain can weigh anywhere from 100,000 to 300,000 pounds and is often heavier than the anchor itself. When the anchor is deployed, most of the chain rests on the seafloor rather than hanging freely in the water. Its enormous weight helps absorb the forces created by waves, wind, and ocean currents before those forces can reach the anchor. As a result, the anchor is able to stay firmly embedded in the seabed and hold even some of the largest ships in the world in position. Dropping anchor is not as simple as lowering an anchor into the water and waiting for it to grab the seafloor. Before anchoring, a ship's officers must determine the water depth and carefully calculate how much chain needs to be deployed. To do this, they rely on a basic principle known as scope. Under normal conditions, the length of the anchor chain is typically about 5 to 7 times the water depth. For example, if the anchorage is 100 feet deep, the ship may need to deploy between 500 and 700 feet of chain. This ratio creates the proper pulling angle, allowing the anchor to dig firmly into the seabed. In rough weather or stronger winds, captains may release even more chain to increase holding power. A small mistake in this calculation can significantly reduce the effectiveness of the entire anchoring system. After learning how an anchoring system works, many people ask an interesting question. If a ship has a problem in the middle of the ocean, why not simply drop anchor and stop? The answer is that an anchor only works when it is connected to a large amount of chain resting on the seafloor. In the open ocean, however, the seabed is often far below the ship. For the anchor to be effective, the vessel would need to carry an enormous length of chain, which is generally impractical from an engineering and operational standpoint. That is why commercial ships usually anchor only in relatively shallow waters near ports or coastlines. Out in the open ocean, where the seafloor may be miles beneath the vessel, dropping anchor is no longer a practical option. In waters that are too deep for anchoring, some ships can still remain in exactly the same position for hours, or even days at a time. The secret is a technology known as dynamic positioning. Instead of relying on an anchor, this system uses computers, sensors, and multiple thrusters positioned around the vessel to continuously counter the effects of wind, waves, and ocean currents. The computer monitors the ship's location in real time and automatically adjusts thrust every second to keep the vessel at its target position. This technology is commonly used on offshore drilling ships, research vessels, and other specialized ships, where drifting just a few feet from the intended location could create serious operational problems. When a ship drops anchor, the crew cannot simply estimate by eye how much chain has been released into the water. In fact, anchor systems use a simple method for measuring chain length that has been used in the maritime industry for centuries. Rather than being made as one continuous piece, an anchor chain is divided into standard sections known as shackles or shots. Each section is typically about 90 feet long and connected to the next by special joining links. To make them easy to identify, these connection points are usually painted or marked with clear indicators. During anchoring operations, sailors stationed at the bow watch these markings as the chain passes by. By counting the number of sections released into the water, they can quickly determine how much chain is deployed and report the information to the captain, helping ensure the anchoring system performs exactly as planned. Many people assume that an anchor begins holding a ship in place the moment it touches the seafloor. In reality, that is only the beginning of the process. When first deployed, the anchor usually rests on the seabed and provides very little holding force. For the anchor to work properly, the ship must continue drifting or move slowly under the influence of wind, currents, or controlled engine power. As this happens, the anchor chain begins pulling the anchor at a nearly horizontal angle. This pulling force causes the anchor's flukes to rotate downward and gradually dig into the mud or sand beneath the seafloor. The greater the pulling force, the deeper the anchor tends to bury itself, and the stronger its grip becomes. This is the moment when the anchoring system transitions from simply being deployed to actually holding the ship firmly in position. Once the job is done, the entire anchoring process has to be performed in reverse. To do this, the ship relies on a powerful mechanical system at the bow to haul the anchor chain back on board. When anchor retrieval begins, hundreds of feet of heavy steel chain are gradually lifted from the seafloor. During the early stages, most of the effort is spent raising the enormous weight of the chain itself rather than the anchor. At this point, the anchor may still be firmly embedded in mud or sand beneath the seabed. As the ship slowly moves toward the anchor's position, the direction of the pulling force begins to change. What was once a horizontal pull along the seafloor gradually becomes an upward pull. This change in angle helps break the anchor free from the seabed and allows it to be lifted back to the surface. The anchor and its chain are then secured in their storage position on the ship, ready for the next deployment. Although anchoring systems are designed to be retrieved easily, anchors can sometimes become stuck on the seafloor. This may happen when an anchor becomes caught on large rocks, shipwrecks, underwater pipelines, or other objects hidden beneath the water. In these situations, the crew will usually try changing the ship's position and pulling from a different direction. Some vessels also have specialized procedures and equipment that can help free a trapped anchor. However, these efforts are not always successful. If continuing to recover the anchor could damage the anchoring system or compromise the safety of the vessel, the captain may be forced to abandon the anchor along with part of the chain in order to continue the voyage. While rare, this is a situation that every sailor must be prepared to deal with. Even after it has been lifted out of the water, an anchor's journey is not quite over. Before the ship can continue its voyage, the crew must make sure the anchor is returned to its proper position and secured safely. As the anchor handling system continues operating, the anchor is guided back to the bow through a dedicated passage. Once there, it is pulled tightly against the hull and locked in place using specialized securing equipment. This step is especially important because an anchor weighing tens of thousands of pounds could shift or strike the ship if it is not properly secured during rough seas. For most of a voyage, the anchor remains in this position. It is used only for brief periods, yet it plays a critical role in the safety of the vessel whenever it needs to stop at sea. Whenever a ship comes to a stop at sea, most of what makes that possible remains hidden from view. Beneath the water are massive chains, invisible forces, and an entire system engineered to work reliably in one of the harshest environments on Earth. For most of a voyage, the anchor simply rests at the bow, unnoticed by almost everyone on board. Yet when the moment comes, it becomes one of the most important systems on the entire vessel. Perhaps that is what makes engineering so fascinating. Some of the most important technologies are not the ones we notice the most, but the ones quietly working in the background to keep everything else running smoothly. If you enjoyed this video, don't forget to subscribe to Mido Explained and stay tuned for more stories about the engineering behind the world around us.